All right, it's 11. Let's get started. Hello, everybody. A couple of announcements, really just reminders from last week, or last class. Just don't forget that the Chapter 2 homework for Achieve is due Monday morning at 9 a.m. The Chapter 1 and 2 learning curves are posted on Achieve. Those are extra credit, and they will go towards your overall exam grade. You have until next Friday to complete them, but they are good review for our Unit 1 exams, which is next Wednesday. I posted an announcement with all of the information about the exam that I shared with you in class, and then some recommendations for studying. That was a comprehensive list to remind you of all of the different resources that you have, in addition to coming to office hours and studying with people in the class. You don't necessarily have to do everything. You can choose from that list what you feel like is going to help you most. So that was the goal of posting that. Again, don't forget I have office hours Monday in case you still have questions before our Wednesday exam. And then I wanted to show you one other thing on Achieve that's available to you. So if you go to our site and you use the assignments tab, you see all of the different assignments that are coming up and are passed. If you go to course content and you see all these folders, go into Chapter 1 or any chapter, open chapter level assessments. This is where the homework is. And then there's also this PDF for each chapter that has answers to odd end of chapter questions. So in the ebook, there's a section that's just end of chapter questions. If you feel like you need more practice, you can use those questions to practice, and then you can check your answer with this. So you get to this through course content, and then if you go to the ebook, I just after open chapter 1, at the very end of chapter questions. And there's just a bunch of questions in there. So you can do that for chapters 1 and 2 to prepare if you would like some extra practice. Don't forget that when you're here taking the exam, you won't have your notes with you. So it's helpful to try some of these questions without your notes, see how you're doing without the chapter notes, and then that will help you identify, hopefully, areas where you might need to study more. Okay. Any questions about logistics? Yeah.
I was just wondering, for the exam, is it really kind of similar format as the sheet where it's like the questions, like the kind of the math questions, or is it more like definitions and putting notes?
So it's going to be a mix. There's going to be more multiple choice questions, but those will have a mix of like some quicker calculations and conceptual information, and then a few short answer questions, which will be more involved calculations. Okay, yes. I don't have an answer yet. It's not done yet. Is it like what? Oh, a 15 would probably be the max because we only have 50 minutes, so I want you all to be able to complete it in 50 minutes. Yeah. 15. 1-5. Yeah. You have 50 in 50. Okay, quicker question. Yeah, so you'll be doing some calculations that'll take more than a second or 1 minute, I guess. Okay, don't quote me on 15. I'm not done writing the exam yet, so. But they will not be 50. I know that for sure. No. Unless it's the short answer, those could have multiple parts, but not the multiple choice. Okay, let's continue with our chapter 2 notes. So, at the end of class on Wednesday, I'll actually go back. We were talking about different types of atoms. Atoms have protons, neutrons, and electrons. Every specific element has the same number of protons. So every chlorine atom has 17 protons. Every hydrogen atom has 1 proton. We can vary the number of neutrons, and we get these different isotopes. We can also vary number of electrons, and we get different charges on the atom. So atoms are neutral if they have the same number of protons. Oops. Oh, not neutrons. Protons and electrons. So if you have an atom has the same number of protons as it does electrons, this is a neutral atom. That's because protons and neutrons have the same magnitude and charge but opposite signs. So protons positive, electrons negative. But atoms can gain or lose electrons, and that causes them to be charged. So they form charged particles. They hold a charge. It could be positive or negative. Electrically charged atoms are called ions. So if you have an ion, it has a charge. It is not neutral. It could be positive or negative. And then we have specific names for positively charged ions and negatively charged ions. Cations are positively charged particles. If something is positively charged, that means it has more protons than it does electrons. So we'll write more. Do you have a question up there? Okay. More protons than electrons if it's positively charged. My high school chemistry teacher always said cations are positive. Look how cats have paws. So if that helps you remember, cations are positive. There's a little helpful. Oh, good. This is a good one. And then anions, that's the term for negatively charged particles. Okay, so we said atoms can gain or lose electrons to form ions. On this slide, we have 2 images that show those different possibilities. So if we're forming a cation, this image is to show cation formation. These are positively charged particles. They're formed by the loss of an electron. So in this image here, it first shows a neutral neon atom on the left. Neon is element 10. It has 10 protons in its nucleus. So if it is neutral, then it also has 10 electrons in its electron cloud. So the positive and negative charges cancel out. If an electron is removed from neon, the number of protons stays the same. So it still has 10 protons, but now it has 9 electrons. So overall, we have a positively charged atom. And we represent a charge when we're using the elemental symbol. I'm not going to be able to point that high. The neon at the top there, we would put plus for a +1 charge, +2 for a +2 charge, etc. And that plus is a superscript. And we do the same thing if we have an anion, the negative charge. So cations formed by losing an electron. Anions are formed by gaining an electron. So remember, anions are the negatively charged particles. They're formed by the gain of an electron. In this example here, we have chlorine. Let's name this picture. So we have anion formation down here. Chlorine is element 17. It has 17 protons in its nucleus. A neutral chlorine atom also has 17 electrons in its electron cloud. If it were to gain an extra electron, then it still has 17 protons, but now it has 1 extra electron. So its overall charge is -1. All right, I have the next slide, some questions. We have 3 different elements with different charges, identifying the number of protons and electrons in each of these ions. This one will be pushed as a quiz. No, it's not, I guess. I didn't prepare this one, so that one won't be pushed as a quiz. So not an iClicker. So using the periodic table, you might have to go back a couple slides if you don't have one printed out. Identify protons and electrons, and then we'll go over this one together. All right, let's go through this one together. How many, looking at fluorine, how many proteins does fluorine have? 9. How do we know fluorine has 9 protons? Thank you. Yes, if we look at the periodic table, fluorine is element 9. That tells us there are 9 protons in the nucleus of fluorine. So we have 9 protons. And then someone from the other side of the room, how many electrons does fluorine have? It has 10, yes. And we know it has 10 because It has a negative charge, so it must have one more electron than it does proton. All right, how about magnesium? This is element 12, so we have 12 protons. Plus 2 charge means 10 electrons. So we have 2 more protons than we do electrons. And then lastly, nitrogen is element 7. And thank you, 10 electrons, because we have a minus 3 charge, so 3 more electrons than we have protons. And that's about it for that section. Questions before we move on, though? It doesn't sound like chemistry. As important as Wendy's is, atomic masses are more important right now. Okay, so we're going to talk about atomic masses of elements. If you look at the periodic table, for each element, we have the atomic number. So for nitrogen, that's 7. And then we also have the atomic mass, which is a combination of protons and neutrons, and then a weighted average of all the different isotopes for different elements. So the atomic mass, remember this is different than atomic number. Atomic number is protons. Atomic mass for one isotope of an element is the sum of the number of protons and neutrons in the isotope. We talk about atomic mass units, or we talk about atomic mass in units of atomic mass units. That's abbreviated as AMU or just U, all lowercase. And the atomic mass for each element can be found on the periodic table. For example, the atomic mass of Na, which is sodium, is 22.9 atomic mass units. This question will be an iClicker. So the goal here is just to identify these elements on the periodic table and then select the atomic mass. There is a typo for hydrogen, so we'll get to that when we talk about hydrogen. So just don't answer hydrogen yet, but find the atomic mass of hydrogen. Yeah, I'll in a minute I'll say what to do for hydrogen.
Wait, there's only 2? Oh, carbon.
So for hydrogen, if you look at the periodic table, what's the atomic mass for hydrogen? 1.0078 or 79. 1.008. On this question, input 1.001. That's a typo. So you all should get that one right. That's the one that's marked as correct, but it is 1.008. Okay, and then I'll wait 20 more seconds, and then I'll end it, and we'll talk about the other two. Okay, ending it now. Okay, so if we look at calcium on the periodic table, this is element Ca. I don't memorize what the atomic number is. Does anyone have the periodic table and can tell me? Anyone have the atomic number of calcium? That's the atomic mass, yeah. 40 is the atomic mass. The atomic number is 20. I'm asking for atomic number, but you're right. The question is about atomic mass. So it's element 20 on the periodic table. And if you find element 20 on the periodic table, its atomic mass is 40.078. Carbon is element C. Its atomic number is 6. And then its atomic mass, someone on this side? 12.011. So remember that atomic masses that are on the periodic table are an average of the different isotopes for that element. So carbon, its common isotope has 6 protons and 6 neutrons, so that would be a mass of 12. But there are other carbon isotopes that have a higher mass, and so that's why its recorded mass on the periodic table is a little bit higher. That's 12. Yes. Okay, so yes, its mass is 1.0078 or 1.008. On the iClicker question, the response that I marked correct was 1.001. So I was just telling you all that that's what to input on iClicker. I didn't have this as an option, but this is the correct mass. Yeah. All right, so if we know the masses and the abundance of different types of isotopes, we can calculate that average atomic mass that's reported on the periodic table. So we use this calculation here where the elemental atomic mass is the sum, this capital sigma Greek letter implies that we're taking the sum of any isotope mass multiplied by its fractional abundance, and then we would do that for all the different isotopes and add them together. So here's another example. Hydrogen atomic mass is 1.008. Hydrogen with 1 proton has an atomic mass of 1, so that's the most abundant isotope, but again, there are other isotopes of hydrogen that have a neutron, and so it's a little bit higher mass, so the average is higher than 1. So let's do this example on the next page. For copper, it has 2, at least in this question, 2 naturally occurring isotopes. One is copper 63, and that has a 69.17% abundance. The more precise mass is reported here, so 62.9396 atomic mass units. That is 69.17% abundance. Then it also has 30.83 abundance of copper 65, more specific mass here with this abundance. So to calculate the atomic mass, we multiply the fractional abundance by that isotope's mass, do the same thing for the other isotope, and add them together. So I'm just going to copy over that equation. So we do this sum of the fractional abundance times the isotope mass. This is an equation you should remember how to calculate the average atomic mass with different isotopes with different fractional abundances or percent abundance. So now we do this for each isotope. We multiply its abundance by its mass. We convert the percentages to decimals. So we will do, for the copper 63, 0.6917 as its fractional abundance times the mass that's provided. So that's for copper 63, and then we do the same multiplication for copper 65, fractional abundance 0.3083 times the mass. You could plug this whole equation into your calculator. I solved each multiplication individually. So this first is 43.53532. And then we add 20.01724. This gives us an elemental mass, if we add these together, of 63.553 atomic mass units. We didn't do sig figs yet. We are going to do sig figs. Before we do that, let's think about if this makes sense. We have two naturally abundant isotopes. One is about 63, the other is about 65. And the isotope that has a mass of 63 has a much higher abundance. So we would expect the overall mass to be closer to 63, but a little bit higher because we are factoring in a higher atomic mass for the other isotope. Talk to the people around you to identify how many sig figs should be in the final answer. Oh, okay. So in the first that would give us that's percentage. So then the answers thinking about sig figs would be 43. Okay, we all hold up number of sig figs that you think. Okay, 4 and maybe a 5 and some unsures. That's fine. So in this question, we have both addition and multiplication. In the first step, we have two multiplication equations that we're doing. When we multiply, we just use the lowest number of sig figs and apply that to our answer. So we have 4 sig figs here and 4, 5, 6 sig figs. So our answer here we would say as 4 sig figs. We do not round yet though. We round at the very end, but that would say up to this number is significant. Same thing over here, 4 or 6 sig figs. So we're at this value, or that place is the significant place. But again, we don't round yet. So in this step, we're doing addition. When we do addition, we report up to the significant decimal place. So we can report up to 2 decimal places for addition, because that's what the significant digit is in both of these. So we can report 2 decimal places in the answer. Oops. So 63.55 with sig figs. So 4 sig figs. Okay. Questions about this? Yes.
Is A and U the same as just the U?
Yes. Yeah. Okay, we're going to move on to the last section of chapter 2, all about the periodic table. So we'll talk about different groupings of elements in the periodic table and classifying different groups of elements based on their location. So the periodic table organizes elements into groups that have similar chemical properties. So elements in a group or a column have similar chemical properties, and we'll talk about specific columns of elements. Every known element, we've talked about this in the past, is listed in numerical order based on its atomic number, so its number of protons. There are 7 rows in the periodic table. These are also called periods. And then there are several columns, which are also called groups. Usually when we're looking at a periodic table, these 2 rows right here, these are the lanthanides and actinides. These are listed below the rest of the table, and everything else is kind of shown together. That's how the rest of the periodic tables look in our notes. That's what how most of the periodic tables are represented. But you'll see that the elements that are in the 2 rows listed below belong right here in the periodic table. So we'll see a different version of this. So we have 3 kind of overall types of elements that we talk about on the periodic table, and they are organized in different sections of the periodic table. We have metals, nonmetals, and metalloids, which are also called semimetals. So metals are good conductors of heat and electricity. They're typically shiny. They are malleable, And for the most part, they're solid at room temperature, except for mercury. Did anyone look up a video of mercury, what liquid mercury looks like? Okay, a couple people did. If you haven't already, I still recommend that you look it up, just see what it looks like. So these are properties of metals. Non-metals, those properties are a lot more variable. They're poor conductors of heat and electricity, but generally their properties vary across non-metals. And then metalloids are dull appearing. They are solids, but they're brittle. They're sometimes called semiconductors as well. So these are kind of three main groups, types of elements, and then we can get more specific, which we are going to on this slide. So this slide is color-coded, and if you have a printed out or your own kind of black and white version of the periodic table, it might be helpful to draw in or color in these groupings, but these are just some important groups. First one is hydrogen. So hydrogen's in the first column, but it doesn't have the same properties as the other elements in this first column. It's kind of on its own. It's a non-metal. Everything else on the left side of the periodic table are metals. So that's why hydrogen's kind of a different color here. Then this first column, we have the alkali earth metals, or sorry, the alkali metals. That's column number 1 except for hydrogen. One more to the right, we have alkaline earth metals, column number 2. In the center here, we have transition metals. These are often grouped into transition metals, but we can also specify that this row is the lanthanides, this is the actinides. You'll see that there's an atomic number gap right here, 56 to 71. That's because all of these belong in that spot, 57 to 70. And then same thing with the next row. Okay, so transition metals, lanthanides, actinides. These are main group elements. We just don't really have a useful, at this point, names for these groups. And then we have halogens, so this is the second to last column, and then noble gases as the last column. In this periodic table, and in the one you're given for ACS, the columns are listed from 1 to 18. On other periodic tables, they're also listed where we have groups 1A, 2A, and then we skip over to 3A all the way to 8A. That's because all of these, now these are right here listed as the main group elements, but really all of these that are listed 1 to 8A are main group elements. There's another image of a periodic table that shows that. So those are 1 to 8A, and then the transition metals in here are listed as 1 to 10B. 10B. We'll come back to this table when we do some questions. I don't really have much to say about that right now. So let's go to periodic properties. So the 2 slides ago showed you where these groups are on the periodic table. We'll go through some of these properties here. We're going to start on the right side. So group 7A or group 17, these are halogens. They're abbreviated often as X. So the capital letter X can represent any halogen in that column. That's common all the way through organic chemistry. And then pure halogens exist as diatomic molecules. So if we go back to the periodic table, we have the halogens, group 7A or group 17, fluorine, chlorine, bromine, iodine, etc. In nature, these exist as diatomics. So we have fluorine or difluorine, dichlorine, dibromine, etc. Group 8A or group 18, these are noble gases. And these elements are chemically inert, meaning they typically do not undergo chemical reactions. It is possible for some of these elements to react with other elements or compounds, but they are relatively unreactive compared to all other elements. They occur in nature as gases, and then they glow in distinctive colors when exposed to an electrical discharge. So neon is a noble gas. Neon is used in a lot of signs. You've heard of neon signs, seen neon signs. Here's neon, the second one, what it looks like. And so it's used in signs for like storefronts because it will glow when exposed to an electrical discharge. Now we're going back to the beginning of the table. So group 1A, or group 1, these are alkali metals. They are metals, they are solids, they are soft and shiny. They combine with halogens, so halogens are group 7. They combine with halogens in a 1-to-1 ratio. So if A represents the alkali metal, we can represent alkali metal and halogen generally by AX. Some examples are sodium chloride. This is a common salt. Sodium chloride, sodium is an alkali metal, chloride or chlorine is a halogen. Lithium bromide is another example, etc. Next group over from alkali metals, so group 2 or group 2A, these are alkaline earth metals. They resemble alkali metals, but they have some different properties. They don't combine with halogens in a 1-to-1 ratio like alkali metals. They combine in a 1-to-2 ratio. So we can generally represent that as AX2. And then some examples here, we have calcium, Ca, which is a alkaline earth metal, and chlorine, then its compound would be CaCl2, so 2 chlorines for 1 calcium. Same thing, MgBr2 and others. Elements in group 2A react with atmospheric oxygen to form solid oxides. So calcium would react with oxygen to form calcium oxide, magnesium, magnesium oxide, and others. These are formed in a 1-to-1 ratio, where 1 alkaline earth metal with 1 oxygen. So all of the groups that we've talked about so far are part of, do you need me to go back? Anybody? Okay. Let me know if you ever do. Other groups that we talked about so far are part of the main group elements, so groups 1 and 2, and then 13 to 18, or 3A to 8A. These are main group elements. Some of the columns are specific, so alkaline or alkali, alkaline earth, halogen, and noble gases. And then we have these transition elements. So transition elements are in groups 3 to 12. Transition metals, and then they are subdivided where we have these inner transition elements, the lanthanides and actinides. And then just to reiterate down here, groups 1 to 2 and 13 to 18 are main group elements. And then we have these metalloids. These are found along a stair-step division of metals and nonmetals on the periodic table. So I'm going to quickly go back to that black and white periodic table. The metalloids, starting at the top here, include boron in row 2, silicon in row 3, germanium, arsenic, As, Sb, Te, and then the next row right here depends on what periodic table you're looking at. Sometimes these two elements are included in metalloids, sometimes just a T, sometimes they're not. So you see in this picture, they're not. So here's what we'll do. We'll include them right here, but I won't ask you about these two. Okay, questions about these groupings on the periodic table? Yes.
So what is that group that you highlighted?
Oh, so these are the metalloids. So I don't know what slide number that is, but towards the end of the PowerPoint, these are the metalloids. And then you reminded me, I went back to this slide to show you. We have the metalloids in the stair-step sort of fashion here. Everything to the left are metals, and then everything to the right of them are non-metals. So the metalloids kind of in between. So here are the metalloids. Metals to the left, non-metals to the right. And then let's do this last question here. So we have 3 elements. Classify them as main group metal, main group metalloid, main group nonmetal, or transition metal. These elements, so these are some of the elements that you should also remember the name. So you might just give yourself some extra practice here. Write the entire name of these elements. Write protons, electrons, neutrons, things like that. All right, let's talk about these and then we'll be done for today. I'm going to go back to that periodic table. The first question was about CS, which is cesium, right here. So column 1 on the periodic table. Is that a metal or non-metal? The metal to the left of the metalloid, so that's a metal. And then main group or transition? Main group, okay. Bromine, all the way to the right over here. This is to the right of the metalloid, so it's a non-metal, and it's part of the main group. So we have a main group non-metal. And then our last one is uranium at the bottom here. And this is part of the transition metals. So transition metals are these in the center here, and include these 2 rows, technically these 2 rows below here. So these are intertransition metals, and then we can say these are lanthanides, these are actinides, but still considered transition metals. All right, that's the end of chapter 2, so that's the end of everything that will be on the Wednesday unit exam 1. We will start chapter 3 on Monday, and I'll post an announcement when those PowerPoints are available. Right.